like really inspiring and rewarding just for them to see what they do and like both in terms of what they give back to the community, but also what they achieve and do at the conferences, like the stuff they present, the stuff they choose, the blog posts about what they do. They work with S&P 500 and all the stuff like that. So I expect they will be rolling out a whole lot of like tweaks because they have very many like out their sleeve. I'm really looking forward to this one. So I would like you to welcome to the stage and joining me in welcoming Ines and Matt. We will take questions at the end.
Yep, cool. And there'll be stickers, so you'll all be fine. Cool. Yeah, thanks for the intro. I'm very excited to be here today and also do the talk together with Matt. Yeah, a little bit of an intro before we get started. Some of you might know me from my work on, well, know us from our work on Spacey. Spacey is an open source library for what we call industrial strength natural language processing. So it was really designed from day one to be used in real products, in real projects, and in production. And over the years, we've also put a lot of work into like kind of the boring stuff of open source development, like backwards compatibility, making sure that we don't break people's code and so on. And that had more recently a pretty nice side effect, which is that LLMs and coding models and even ChatGPT are actually really good at writing Spacey code. So it's even easier to get started. And another tool, as Luca mentioned, that we work on and that we develop is Prodigy. Prodigy is an annotation tool for creating data for machine learning models. And it was really designed to be used as a developer tool and making data collection and data development a development activity. And of course, it's fully scriptable in Python. After all, we're at a Pi conference. And also, as you can see, like we've really spend a lot of time building tools that are hopefully useful and also very, very powerful. But what we've always found is that it can be kind of difficult to make it easy to really use the tools to their full potential. There's so much you can do, but it can be quite difficult to know what to do, which is take a business problem, translate it into NLP components that you can work on. This is the hardest part before you even start training or doing anything else. And so this is something that I will be talking about, or we will be talking about. Sorry, I'm used to doing talks about that we will be talking about today. And as it turned out, one of the big missing pieces that we found were coding assistants. And AI coding assistants have really transformed the way we build software. And normally, I used to do like a show of hands, like who uses Claude Code or whatever, but I don't even do that anymore because I feel like it's kind of everyone. I think most of us really have used AI agents and assistants to help us write code. And whether you just like you need some help implementing code or a program given tools, that's of course one thing you can do, but especially more recently we've really seen coding assistants also get much better at helping developers pick the right tools in the first place. So and then that also means they can more and more be used to solve a real business problem. So you can give it an example of something you're working on, like analyzing some reports, creating a table, extracting data, and they can write you a program that can do these things, and they'll pick tools, like for example in this case, maybe pandas, maybe you'll do something with Spacey, and then give you a program that can really solve your problem. And that's all really cool. And now you might be looking at this and you might be wondering like why, that's all cool, but like why do we even need to write a program in the first place? Can't we just like tell the LLM, hey, here's the problem, can you solve it? And can we just like, why do we need all of this? Can't we just ask the model to solve it in the first place and answer the question directly?
Okay, so here we make the slightly awkward transition. Okay, yeah. So I think large language models can be kind of confusing to think about and talk about. So to me, it can be useful to actually cast your mind all the way back to when these models started to come around and when we all started to use and interact them. So if we think about using something like ChatGPT when it first came out, well, it's obvious that these models learn a very powerful meaning representation or knowledge representation of the text that they've been trained on. And has been a bit less obvious is how to actually harness that power. So one of the first, ways that came about with that was to basically use them as for computation. So you have the prompt will be the instructions of the program, and then you sort of concatenate in the data, and then it does the computation. So here the LLM is like computing directly, and in some cases this is a good way to go about this, but we all quickly saw that there are a lot of limitations for this, and in a way it's actually weird that it works at all. Like, it's a slightly unintuitive idea. So we all probably saw this type of example of, one of the most prominent where this type of model starts to struggle. So if you have some prompt like, reverse these strings, and then you have, the data of the program is the list of strings, the model really struggles at this. And it struggles at that for reasons that kind of make sense for how it works under the hood. So they happen to use these word piece tokenizations. They actually don't have a very good internal representation of a character-based view, and so even this seemingly very simple task, they would really struggle to do this reliably, because there will always be tokens where if it's a rarer word, then actually even a common word, they'll have these chunks which, where they don't know the characters. So it doesn't know that strawberry is spelt like that. It thinks of it as a sequence of tokens. So what do you do instead to actually get it to, do the task well? Well, the obvious solution is that instead of using it as computation, well, the next step is to actually write the code. So this is kind of like, if I ask you to, go to London, you don't start walking in the direction of London, you start walking in the direction of your computer to buy a ticket, to buy a plane, to go to London. The shortest distance isn't necessarily just like heading straight there. It's taking steps to actually set things up. And so similarly, when we started to train these models to be good at actually solving problems in a step-by-step way, well, the first step to solving this sort of problem is write a program to do it. And there's many of these situations where the best thing to do isn't to just do some computation, it's to write a program to do some computation. And so the example of reverse some strings is a bit of a lob. It's a soft example of this because it works particularly on limitations of the underlying representation. But in fact, there's many of these situations where using it directly as computation is an unideal situation. So also for listing the company names in text, it can read them and use its internal knowledge and come up with a list of company names. But it's not necessarily the ideal way to do it, and it's instead you can write a script to extract the company names from text. Well, how do you write such a program? Well, you use machine learning. And so the question is, how do we get coding assistants to be better at this type of task? Because writing programs that use machine learning is a particular type of software development skill, it's a particular type of software development process. And we all found this when machine learning started to become more prominent. There was this sort of upskilling of software developers to do this type of work more effectively. And it's not only the process of writing a single script, there's this interactive step of writing scripts, executing things, writing once-off processes, reasoning about the next steps to do things. So what we've been trying to do is actually get coding assistants to be better at this job, which is a little bit different from just writing code. The question, so what we're trying to do is, instead of using the LLM as the system, like using it as the processing module, using it as more of the part that creates the system. Okay. This is very much in the same theme. If we want to sort documents into custom categories, well, one of the steps to do this, one of the core development tasks of doing this type of machine learning work is actually creating the example data. And so that's a core part of the challenge, and this is a part that we've really tried to develop software to make easier and more effective.
Yeah, and here in this example, as you can see, the result, like if we are following this workflow and we're using the LLM not only, not as the system, but to create the system for us, suddenly there's a lot of cool things we can do here. For example, if we want to sort documents into categories, instead of just having the LLM do it, we ask it to create data for us that then lets us train a custom classifier, and that means the result we end up with has a lot of advantages, and it's clearly, in a lot of cases, a superior workflow. We end up with models that are pretty accurate. We can make them much more accurate at our task because it's so specific, and we have data. We have models that can be really fast. They're also small. We've had one case study where they managed to train a 6 megabyte model, and just imagine, all the possibilities you have if, that is the AI you're running. You have these, if you can run these components yourself, they're fully data private. You don't need an API that you send stuff to. It's also, I think, something people are noticing much more now. If, you've followed this LLM maximalist approach, and everything's like an LLM API call, and now you're getting your cloud bill and you're like, oh shit, this is not so good. Like running a small model is a lot cheaper. And you also can follow a lot of these software development best practices where just having one model to rule them all, do everything, has never really felt right in a software development workflow. You want solutions that are modular. You want things that are transparent, that you can explain. And all of that is really difficult if everything is just one API call that does everything. So breaking things up into smaller components is also something that's really a huge advantage here. And now if you're looking at this, one obvious question is if this is all so much better and so superior, why are we not doing more of this? Why aren't we just going and just training lots of classifiers? I mean, it clearly has a lot of advantages. And I think there's several reasons that we've seen, why we don't do that. One of them is obviously, if you've done a machine learning project or NLP project before, everything is lots of steps and you have to do many different things, just starting with even breaking down the problem. You have to create data, you have to evaluate ideally. There's so much you need to do. So it's, pretty operationally annoying. And so, people don't really do that or don't have time to do that. It's also operationally complex. You need, suddenly you need ML ops, you need infrastructure, you need to run stuff, you need to monitor all the things you're doing. And that's, I think a reason, LLMs to, kind of this maximalist approach where you ask an LLM to do everything. A reason that has caught on as well is because it's just simple. It's one operation. You don't have to think about all of the stuff around it. And then finally, I think, even one of the more important things is, you need to know what you're doing and you need this kind of expertise. And ideally, this is the stuff you don't necessarily get from going to university. You really need to have solved these problems before, or you need to have made a lot of mistakes and learned from them so you don't make them again. And that often takes years of experience in the field. And so if you don't really have that, it's a lot harder to make your problem work, and then you have things that fail, and then people might not even get started or might not even do any of this. As Matt said, that is really what we've been thinking about. How can we make all of these things easier and help people get over them? Because if we're looking at traditional software 1.0, which is you writing a program and creating an code artifact, coding assistants are actually pretty good at that these days, really good, or kind of good, depending on what you're doing. It depends, but this is really a problem we're getting much closer to solving. But with software 2.0, which is code plus data, we suddenly have this whole other dimension. We have the data in it. It's not just, you're running lots of different things. You're not just producing some code. So that adds a lot of difficulty. And the question is, how can we bring the sort of agentic workflow that we have for code development, how can we bring that to software 2.0 as well, and also use it to create code plus data and build these systems that are a lot better in a lot of dimensions. And that's something we've been thinking about a lot, we've been working on, and what this led to is a new tool that we're calling ELF. It originally stands for Explosion Large Language Framework. It was kind of a working title, but then we saw the domain was available and it kind of stuck as a name. So this is ELF. And one thing we've definitely saw very early on is that we really want to work in an environment that people are already familiar with and that is able to do all the coding and everything else. And that is your coding assistant like Claude Code. And that's what we wanted to integrate integrate with, and that's kind of the first step. And we wanted to give the agent tools to solve these NLP problems. So be able to not just ask it to write code, but ask it about a real-world problem that you're solving, and having it be able to answer this, create a plan for you, and generate the next steps and tell you what to do. And essentially, that also includes all of our distilled experience from over 10 years of solving these real-world problems in industry and writing about it and giving people advice and publishing best practices. And we wanted to distill all of that knowledge into the coding assistant to make that first step easier. So that's the first thing we focused on. And usually the first step is, well, you describe your problem, you want to break it down into a plan and next steps. So in this case, your first step is usually to create a project plan that you can work through. And if you have a project plan, you can send your agent off to work through that and support you along the way. And under the hood, one big part that we also started developing first, and a central component, are these workflow modules. So you've probably, if you've used Claude Code or similar tools before, you're familiar with skills. So we've added a lot of these that cover different parts of the NLP project lifecycle. So for example, we have the general project advice that we've already seen. We have workflow modules focusing on annotation, and especially annotation is not only like labeling data, it's stuff like how do you even break the problem down? Which labels make the most sense for humans and for machines making these kinds of decisions? Then we have our annotation tool Prodigy, so there was a lot we could make easier there to use it, both by writing code for it, but also integrating with agents. So agents can do annotation for you. Often another problem that's often overlooked is making the decision, when do you even need machine learning in the first place? Because there are other things that you can solve much better with deterministic rules. So you want to have a workflow that lets you interactively discover when should I even train a model, and when can I maybe rely even on something as basic as regular expressions, which will be a lot faster and a lot more accurate and predictable. Then, of course, you want to train a model, but that's a lot more than just running the training run. You want to interpret the results. That's also something normally you need a lot of expertise for. You see like a table of numbers. What do they mean? What does it mean if the number here goes up or down? Or how do I interpret the loss? Things like that. That's really what made this whole process pretty difficult and pretty unpredictable. But so you want to have tools that give you that information and tell you what to do next. Should you create more data? Should you look at your code? And so on. And then finally, just general question answering. There's like so much advice that is important for NLP, and you want to have a good way to access that. And all of this is implemented as skills. Again, if you've used the coding assistant, you're probably familiar with that. You can add all kinds of skills. Soon, once we're out of beta, we also want to open source these. So the general NLP advice you can easily add to your coding assistant. And then, of course, on top of that, we also have some specific ones that are really specific to the tool and working with ELF that we also have included. Now, this is all very cool and actually, works really well. It's very exciting. But very quickly, we saw that compared to traditional software 1.0, where what you produce is a code artifact, NLP is really different in a lot of ways. And one thing that really stands out is that if we're doing NLP or AI or machine learning, we need to run lots of stuff. And that's kind of different than just running a few bash commands or testing here. We have things like training. We want to optimize our training. We want to analyze things. We want to do all kinds of different things here. Evaluate data transformation, so much data cleaning, all of these kind of annoying things you should do if you're doing it properly. We want to annotate. We want to have agents annotate for us. That all needs to run. And then, of course, you have like so many internal scripts that you wrote or that your agent wrote that also need to live somewhere and be run in the process. And then, of course, what makes it even harder is all of this is somehow connected. Some things need to run in parallel or in sequence and so on. You have hardware stuff as well. If you you might have a GPU that you want to use if you have one available, so that can be tricky. And then you have the data. If you're working with data, another thing is probably your data is very sensitive, can't just easily be sent to all kinds of servers. So you need a way to deal with that. And then of course everything is also really custom. The most important and most valuable use cases for machine learning and AI are usually the ones that are very specific. So you also end up with all of this code, some with a history, and all of this needs to be kind of part of the same thing. So that was very tricky, and the answer is, well, what do we need? We need infrastructure, and especially a Kubernetes cluster that can run, that can run all kinds of things nicely that we want. And a cool thing about coding assistants as well is that they're actually pretty good at all this infrastructure stuff. So previously, you really needed to have infrastructure and DevOps experience to even get the Kubernetes cluster running. But nowadays, this is something that's become a lot easier. So it's a lot more feasible to add that and to have this provided for the user, because what we really want is we want to have the user host this cluster either on their local workstation or in the cloud, so they can run their own Python code on it, they can have their data on it, they can have all files on it, and we never need to have anything passed to our servers or need to run people's stuff on our servers. It's just a cluster that can be plugged in and that can run stuff and also be operated by the agents. So there are kind of three concepts of things it can run. On the one hand, we have tasks, which are annotation tasks. So that's like everything that starts an annotation server, queues up data in some way, programmatically, wherever it comes from, and gives an interface that the human can create data with. Then we have actions. Actions are really batch processes, kind of like a CI process as well. They run. It's very useful, obviously, for training, but also processing data, transforming data, running all kinds of scripts, including custom code in its own process on the cluster with access to all of the data and everything else. And then, of course, we also have agents. These are autonomous workers, and they can create data. So you can assign them to annotation tasks and say, hey, Gemini, create annotations here. Hey, other model, create annotations here. And then human, also create some annotations here. At the end, you want to compare these, create evaluation data, training data. That's, again, all the stuff, if you've done this before, really annoying. So most people kind of don't do it or try to avoid it at all costs. If you can just tell your agent, hey, go and do it, it becomes a lot easier to follow these best practices and these workflows. And when it comes to data development, there is actually, a lot of best practices like splitting up work, creating a pilot annotation project, analyzing agreements. When do models agree? When do agents agree? We kind of, we know all of these things. We can find out about these things, but this makes it like a lot harder to orchestrate everything. And for small projects, again, people don't do it, and then the projects fail, and that's like really unsatisfying and annoying. And so the thing about like auto annotation is that really it works especially well if the tasks are well defined. And here we're kind of back at the best practices and back at the general advice. You really want to have a task and labels that are well organized. That if you have done that first step, which also is annoying and often people skip, then it suddenly also becomes a lot easier to have an LLM automatically create annotations for you, and then combine that with humans who will also have a much easier time creating data. It could even be you yourself. So I think having this integration with the data is like a really important step that I think is often overlooked. And it really also changes things a lot if, for the whole system, if you in the same world and on the same footing, in equal footing with the agent. Like you do your operations, the agent does its operations. You compare and you review, and so you're really working alongside the LLM. You're not working, with the LLM in the loop. You and the agents are on equal footing and work together. And I think that's like a really, really important core piece of the sort of workflow workflow that we want. And we've also found that the collaboration of humans and coding agents was really one of the most important parts of making agentic software 2.0 work. And if you've seen annotation tool Prodigy before, you've probably seen this concept of recipes. These are Python functions that configure a workflow, which could be annotation, but also processing and training and so on. And they're automatically turned into a CLI, so based on nice and Pythonic, you have your arguments, you have your types, you have a little decorator, and then what you get is a CLI that's nice for you if you're a developer, but also this is a prime thing that an agent can use. If you have an automatic, well-structured CLI, the agent can get really good at doing that, and it can run the same operations that you might run either in code or in the UI, because for a tool like ELF, we can actually take this one step further, and we can also create a UI from it. So you get all the advantages of having a software as a service tool where you can log in, invite people, and so on, but with the addition that you can script it in Python, which normally you can't, but because you have your cluster that runs your code, we don't need to run your code, and it can automatically generate these structured representations. You basically have different ways of interacting with the same actions, and with agentic development, this can be very useful. And I think, especially with all of these new types of developments, there are some people that say oh, isn't kind of development free now? Does it even matter whether developers are productive? We have agents anyway, so do we care what the developer API looks like? Why are we even doing this? And I actually believe it's really the opposite. And programmatic interfaces are becoming a lot more important nowadays and not less, because it's much easier to interact with these interfaces, both by humans and by agents. So this is really going to be the collaboration point where we all work together. And so I think, again, extensible APIs and good developer APIs that both humans and agents can learn are nowadays becoming a lot more important. And I think that's also why it's something we focused on a lot.
Yeah, so people have been talking about models of human intelligence and machine intelligence collaboration for a long time. And I think one of the metaphors that really stuck around from this is this idea of a centaur. This actually came about in computer chess around the time when human and machines were around equal in power. That's pretty brief moment where there was that sort of balance of power. And centaur systems were systems where a human would operate a machine or have a machine intelligence, and then you combine those two capabilities. And for a while, this was actually better than either a human or machine. So this is it's an interesting conceptual metaphor. It gives you this idea of the powerful horse engine body, and you're there piloting it around as the head, galloping around the plains and having all of that power behind you. But more recently in agentic development, or in the context of LLMs, there's this idea that's been introduced, I think, by Cory Doctorow, of the reverse centaur. And so this is, kind of the opposite, where instead of, the powerful horse engine, it's you're the ass, basically. The horse's head is piloting you around. And this is an anti-pattern that really happens, and is really something to think about as a problem. So why this happens is because you're often engaging with the AI in a system where there's a different conceptual model, or a different collaboration model, where basically you're telling it to do things, and it's doing things, but then there's parts of the task which are left over for you to do in the system that even if there's a way to do it via the API, if you have a REST API that's operating under a very different conceptual model or a different vocabulary from the system that you're looking at, you're thinking in terms of tasks which, the agent tells you, well, go to the system and, we need this itemized or something. And then that's something which, even if there is a way in the REST API to do it, it'll tell you to do it, and then you have to go and do it. So what we need is systems where there's a single unified thing, because then you don't have this collaboration model where there's all of these extra tasks where the AI is actually ordering you around, and you're clicking through a system carrying out its bidding, because that's very much not what we want to do. So, so from this, we can see that, you know, in order to actually get the power that we want and to be in control of these systems, rather than end up having, you know, being the execution loop, we need to, we still need software, and we still need software that follows good abstractions and good architectural principles. There's this take going around that, you know, the future will be AI systems directly implementing bytecode. I think this is like an Elon Musk thing or something. It makes like extremely little sense. We're still going to need these types of things where there's a model where there's an agreement about what's actually being executed, and, you know, it makes a lot of sense. You know, if we're you know, if we agree that yes, we still need software, well, there's tasks where the best way to write that in software is actually to use machine learning, so, you know, we still need classifiers and things. There's still a lot of tasks where actually that the best way to achieve some task is to, you know, to acquire some knowledge explicitly from data and to encode the preferences about how you want the system to behave in examples rather than in explicit rules and code. And so, and, you know, through all of this, we need interfaces for humans so that you get to tell the software what to do. It's not a, you know, cost of it that you have to tell it what to do. This is a benefit that, you know, we all want. We all want to be in charge of the computer and to actually create systems that we can control.
Yeah, cool. So what can we take away from all of this? Well, I think one important thing that we've seen is that it's really overlooked that, like, there are different ways of using LLMs. And I think the most powerful and the best way we can use LLMs is not using them as the system to do a task, but to use them to build systems. That unlocks a whole you know, new world of possibilities. And I think it's definitely one of the most superior workflows that we should be focusing on instead of a very maximalist approach. And next, as we've also seen, it's really, really important that everything we build and everything we work with speaks the same language. And that includes the apps we use, the developer APIs, and of course, the agents. Only that way we can really ensure like a collaboration on equal footing of humans, tools, and assistant and agents. And finally, Software 2.0, code and data, is a really good idea. Like, it's still the most scalable way to incorporate large amounts of data, which usually we have. That's like a huge asset. The only problem is, well, we kind of improved the workflow a bit, but then everyone got distracted with generative AI, and nobody really focused on, like, how can we make this workflow even better? So Software 2.0, we think, is like a really good idea, but the problem is it's too difficult. And the goal is, if we can make this as easy as prompting an LLM, that's really where we're at, and that means we can use all of these superior workflows. So you know, it's we instead of, you know, inventing new things, we need to look at using the right things and making the right things easy. So thank you. This is actually, these are my details. This is my LinkedIn, but you can find Matt through that as well. And you can connect with us. And of course, if you're interested in some of the latest work we've been doing, we have more details, human written docs, and a wait list you can sign up for ELF. We're currently, like, it's really early days. We're starting with the first beta testers. We're doing some projects as well where we actually bundle in some consulting and work with teams to really solve their problems and allow us to use our own software, because that's what we really found. We need to be users of our own tools to make them better, especially in developer tools. So yeah, you can see all of that. And of course, we'll be around. I have stickers. We'll be around for questions. We can, you know, show you some little demos of Vibe NLP if you have some prompt ideas. Yeah, thank you.
Thank you very, very much. You also mentioned, like, the wrong word, like stickers. They have amazing stickers, as good as the light. Okay, so like pry them open. And I would say, like, I think this was incredibly, like, interesting. Maybe you could show off a demo at the lightning talk. I don't know. That could also
actually,
be one thing.
Yeah, maybe you know, I got to speak a bit more here than Matt, so maybe Matt can show off.
That would be
sign
amazing.
Up if that's something you're interested in.
Yeah, but thanks for the talk. We do have time for a couple of questions from the crowd. Don't be shy. There we go. I see one. Okay. Dai, I'll give you the mic anyway so that you can record the question.
Are you planning to implement some kind of benchmark to see if the skills are making the coding agents code better a task that you are trying to address?
So we'd love to do that sort of thing. At the moment, I almost feel a bit of learned helplessness around this because the models underneath has changed so quickly that even after you do that sort of study, it feels like we would immediately have to repeat the results. So like everybody else in the industry, we're eyeballing this, which are, I'm convinced that Anthropic is also doing, because no matter how much money or resources they have, you can't, it's like the saying that you can't pay 9 women to have a baby in 1 month. There's no way to do the sort of studies that you would actually require to seriously test the workflows that they're putting out, systematically. So we want to, we'll do some end-to-end, we're doing end-to-end testing of the whole thing, which includes our operation of it and seeing how well we complete projects. At the moment, we were able to do things with the whole system about 3 or 4 times faster than we were, without any of it. But we don't have micro-testing of individual skills and stuff. As we think of new ways to do some sort of correlate of that, we'll be looking at that. But like everybody else, we're winging it.
Yeah, we do have that could be another talk in itself, like our colleague Magda worked on this evaluation harness where you can really step through the conversations, but that's also why I mentioned earlier, we want to do solve projects as well. So if we are using the tool and we are shipping projects for users who also get to work on the platform, we can sort of see, we have experience, we've done a lot of consulting before, how long did it take us before and how long does it take us now? And then we know, ultimately it needs to be useful in the real world. That's kind of the most important benchmark. Yeah.
Thank you.
I think we had another question right behind you.
Thank you for the talk. It seems to me that the framework you're building conceptually is not specific only to NLP and could be generalized. And I'm curious to know whether or not right now, maybe twisting the framework, you could solve some computer vision task. Or if you think, if it's a direction you want to take in the future.
Absolutely. I think, any of these ML workflows, we have a bit more experience in natural language processing. So certainly while we're in the stage of, doing projects directly, we're a bit more focused on that. But the tool does support computer vision. It supports audio processing as well. And, I think it's very useful for all of those things, yeah.
I guess we can wrap this up and thank again Ines and Anna for the talk.